Okay? All right, so we know that when we have an equation in this form, y equals mx plus b, what does the graph of that look like? What type of equation is that? Kind of. This is a linear equation, right? It's a linear equation, which means when we graph it, what's it look like? Straight line. It's a straight line, okay? So we know from before that if we have the equation y equals 1/3 x plus 2, this is just a refresher of what we've done before. Bless you.
Thank you.
We can graph this very easily because we know that the slope, which is m, is 1/3, and the y-intercept is 2. So we would go to our graph. Bless you.
Thank you.
Okay, we would plot the y-intercept, and then we would plot the slope. What's the slope? 1/3, which means we
Go up one.
good. So starting here at this y-intercept, we would go up 1, and we would go over 3, and then we could graph our line. It's a straight line.
Is it always a dotted?
No. It shouldn't be a dotted line. I drew that because this is not actually what we're doing today.
Oh,
This is just a reminder, okay? That's a linear equation. Anytime I see a graph or a line, let me rephrase that. Anytime I see an equation in this form, I know it's linear. But not only that, I could see an equation in this form, 3x plus 6y equals 12. I know that's also linear. Now, I won't do it now because I don't want to get you sidetracked, but remember way back in the fall, we graphed using the x and y intercepts, right? Okay, how do I know it's linear? Well, I look at the x and the y. What's the exponent that the x has? No, the exponent.
Oh.
1.
Oh.
And the y has an exponent of 1. That's how I know it's a linear equation. If those exponents, are both 1, then I know that it is a linear equation. Okay? Today, we're going to look at equations where this exponent for the x is a 2. Okay? So what we're going to look at today is graphing quadratic equations. So we have been working with linear equation literally for years. Okay? Now a quadratic equation, okay, this is what you want to write down. This is the new stuff. Okay? A quadratic equation is in the form of ax squared plus bx plus c. Okay? So sometimes it'll vary. Like if that b is a 0, you might see something more like 3x squared plus 5x plus 7 equals 0. You might see something like 4x squared minus 9 equals 0. Oops. Okay. Both of those are quadratic. I know they're quadratic because there's an x squared. The y is not squared. Okay. In this case, in these two examples, there is no y, but we'll talk about that later. It's just the x that's squared. Notice the y is not squared. That if the y was squared, it would not be a quadratic equation. It would be a circle. The y is not squared in quadratic equations, okay? So this is the general form of your quadratic equation. A quadratic equation, when we graph it, looks like a parabola. That's a parabola, right? You can remember it's spelled like parabola. I don't know. I don't I don't speak Spanish fluently, but I like that word, parabola, right? It looks like a bowl. Bola looks like a bowl, right? What is bowl in Spanish? Anybody know how to say bowl in Spanish? Nobody speaks Spanish? Okay. All right. So it's a parabola. Okay. Now, let's talk about the parabolas have special properties. Okay. Let's talk about parabola. Okay. So it has some properties. Just like a straight line, it's going to continue to go in both directions. Okay. It's going to continue. Now, the fatter the parabola is, the more obvious that becomes. So let's say that we had a parabola that was shaped more like this, right? You can see that that's going to continue, not just going out and up. Excuse me. Okay. So it's going to continue. Both lines are going to continue. Another feature about a parabola is that it is symmetric. Okay. Parabolas are symmetric. So in other words, if I were to fold my paper, both sides of the graph would match up. Okay. It is symmetric. This line here, the line that I would fold it on, is called the axis of symmetry. Okay. The line that I would actually fold it on to match both sides is called the axis of symmetry. So these are terms that we have to know about the graph, okay? Okay, this point right here, that's called the vertex. And you'll hear that word used in many, many different circumstances, not just parabolas. It's basically the point where it's changing direction. It's called the vertex. It's cold in here, isn't it?
No, it's perfect. This is perfect. Oh man, I'm free.
Oh, it is 75.
It's pretty hot right now. It's perfect.
Okay, so let's see. So we have an axis of symmetry. We have a vertex. Okay. Now the graph can change or appear different. Okay. So I drew a real simple one. Okay. What I drew was a parabola whose vertex, it's just not a dotted line, it's just really hard to draw on this program. Okay. Okay. I drew a parabola whose vertex is at the origin. Okay. This particular parabola has the equation y equals x squared. That's the equation of that parabola. That is your basic parabola. Okay. That is your standard basic parabola. If I were to graph y equals x squared plus 1, that parabola would look the same, except that it would be 1 unit higher. Okay. Is it like what? Yes, exactly. The absolute value equations. Very good observation. Yes. Okay. So if I were to graph y equals x minus 2 in parentheses squared like that, this one is going to move the parabola sideways, and it's going to move 2 to the right. Okay, like that. When it's inside the function, like it moves the opposite direction of what the number is. Okay? So if it moves to the right 2, okay, so let's look at this one in particular. I'm going to just kind of get rid of these. Okay. So my axis of symmetry is this axis right here. This is my axis of symmetry. It's the line that we would fold our paper on to make the two sides match up. Axis of symmetry. So can you give me, what is that axis of symmetry called? Can you give me the name of it? This is called x equals, what do you think? What's this x value right here? 2. X equals 2. That's how I would identify that axis of symmetry. Okay, that axis of symmetry is x equals 2. Okay. Well, what if, you already got that? Can I erase? Okay, let's see here. So this time, I'm going to write the equation y equals x plus 3 squared minus 2. So let's just graph that, right? Because we learned how to do this with our absolute value equations, right? So here's just x squared, right? There's x squared. What's the minus 3 going to do? I mean, the plus 3 going to do?
Turn in the minus.
Yeah, so it moves it to the left 3. So now it's over here. What's the minus 2 doing? Down 2. So we're going to move the whole thing down 2. So there's my graph, or that's, I should say, that's a sketch, a rough sketch of my parabola of that equation. Okay. Is this parabola, is it going to cross the x-axis? Yeah, because remember, we said it continues to go, right? So it's going to cross the x-axis. What's the axis of symmetry? How do I identify that axis of symmetry? Good. X equals negative 3. That's my axis of symmetry, right? So if I was drawing it on a piece of paper, that's the line I would fold it over on, right? How about the vertex? The vertex is a point. It's this point right here. Negative, we need an x and a y.
Negative 3.
Good. Negative 3, negative 2. So I've identified some key parts of that parabola. I identified the axis of symmetry and I identified the vertex. Okay. I'm going to give you one to do yourself. I want you to just sketch where it is. Give me the axis of symmetry and the vertex. Okay. Guess it would have been quicker just to draw a new axis, huh? Okay, so let's look at y equals x plus 4 squared plus 3. So give me the axis of symmetry and the vertex. Okay. Okay, yep, let's do the first one together, right? So what is the vertex? 3, -4. Okay. So I'm going to put a point on 3, -4. So 3, -4. I put a point there. Okay. What's the axis of symmetry? X equals +3, right? So we're just going to put a little dotted line there. Again, this is not actually part of the graph. This just helps us graph it. Okay. We're just doing a rough sketch of the graph because we don't know the exact shape yet. For now, we're just doing a rough sketch. So all I'm asking you to do is just do that. And that's it. Okay? It's not exact, and that's okay for now. Okay, so we did the first one. All right, the second one. So we've got a vertex of what? 4, 1, and an axis of symmetry. Very good. Perfectly stated. Okay, so we're going to go ahead and graph that. So we're going to plot the point 4, 1. There's my vertex. Here's my axis of symmetry right here. Oops. It's actually really easy once you learn it. Isn't that how it?
I love this. This is from
Okay, questions on that one? Okay. Next one. Let's see. Ava, what's the axis of symmetry? For number 3. X equals -2. Very good. Okay. Shayna, what's the vertex?
I put +2 and +2.
So, okay, very close. But remember, we always take the opposite of what's inside the parenthesis. So it's actually -2. There's a reason for that. I'm just choosing not to go over that right now because it complicates things. Okay.
So we keep the one on the outside positive?
Yes, keep whatever this sign is on the outside. Do the opposite of what's on the inside. Okay? Okay, so we're going to graph that -2, 2. Here's my vertex. This is the imaginary line here, the axis of symmetry. And it's positive, so it's going to open up. I don't think I gave you any negatives, right? Okay. Next one. Mason, what's the axis of symmetry?
Now, wait, are we eventually going to have to worry about where the lines, go? Like, how far up they go, or?
You're going to have to worry about having a more accurate shape, whether it's fat or skinny. We're going to learn how to do that. Okay. X equals 4. Excellent. All right, x equals 4. There's my axis of symmetry. Okay. Vertex. Hunter, what's the vertex?
4, +2.
You're close. We keep the sign that's outside, so it's 4, -2. Good. And again, it's also opening up because it's positive. And when I say positive or negative, I'm talking about what's outside the parenthesis there. Okay? Okay, so that's the vertex form. Let's go back and I want to look at, if I can get over there. This is just not, come on. Come on. There it goes. Okay. So what do you notice about all of the vertices, right? Plural for vertex is vertices, right? In relationship to the axis of symmetry, right? There's my vertex, right? Here's my vertex here. What do we notice? Where does it always fall? It always falls on the axis of symmetry. The vertex is always on the axis of symmetry. So let's look at an equation. This time we're going to look at the standard form. These are a little bit harder to graph, but we find that we can find other information from them. So for instance, let's look at the line y equals x squared plus 6x plus 8. This is standard form. Okay? Now, we can't look at it and just determine the vertex and the axis of symmetry by looking at it, okay? So what we can determine, though, is where it crosses the y-axis. Okay? So it's going to cross the y-axis right here. The c value, ax squared plus bx plus c, right? Y equals, right? The c value is where it crosses the y-axis, the y-intercept. So this particular graph, or this particular parabola, is going to cross the y-axis at 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. That's really the only thing that we can just see without doing any work. So now we've got to do some work so that we can figure out where the vertex is and where the axis of symmetry is. Okay? Everybody good with that so far? Okay. So the axis of symmetry, we're going to do that first. We always do the axis of symmetry first. Okay? Now, when we were in vertex form, the axis of symmetry was x equals something, right? It's still going to be the same thing. We're going to do x equals, and we're going to do negative b over 2a. That means that we have to look at the equation. We have to identify the a, b, and c, right?
Why is it negative?
It's just the way the formula works out.
Okay.
Okay? So in looking at this equation, what does a equal?
X.
Well, it's the number in front of the x squared, which is 1. What's the b?
6.
And the c we know is
8.
8. Okay? So when it's in standard form, I identify the a, b, and the c. Okay? Now I'm going to go ahead and use this formula. So it's negative b, which is 6, over 2 times 1. So it's x equals negative 3. Negative 6 over 2. Okay. So I'm just going to sketch that axis in there. 1, 2, 3. I'm just going to put a dotted line there. Okay, there's my axis of symmetry. Okay, everybody good with that? Oh, it is. I'm sorry. Thank you. 1, 2, 3.
Oh, is it because it's opposite?
Thank you. You're confused? What are you confused on?
Maybe, can we just do another one?
Yes, let me just finish this one. We haven't finished yet.
Wait, so it's opposite?
I just using the formula, I got negative 6 over 2, which is negative 3. Okay. Okay. Now let's go. I'm going to go back to that worksheet.
So that's the answer?
No, we're not finished yet.
Okay.
Okay. I want to go back to the worksheet. Okay. Now let's just look at this little for a minute. Okay. On this worksheet, we have their axis of symmetry. We know the vertex always falls on the axis of symmetry. The axis of symmetry says x equals negative 2, right? X equals 4. X equals 3. X equals 4, right? Notice the vertex is 3, negative 4. 4, 1. Negative 2, 2. 4, 2. So what do you notice? The x that we got as our axis of symmetry becomes the x in the point, right? The x that we got from our axis of symmetry becomes the x in the vertex. Okay, let's go back to the problem we were just doing. We found the x equals negative 3. So now I'm going to look at my vertex. I know the x is negative 3. Does everybody understand that? Okay. Give me a fist of 5 on that part so far. Okay. Now, what I need is the y. Is there any place that I can put that x value in to find y? How about right here? Okay. Let's look at that equation. Y equals, it tells me. I want to know what y is, right? I'm like, oh, let me see. I know x. How do I find y? And somebody like Katie runs up and goes, y equals. Okay. Well, gee whiz. Y equals x squared plus 6x plus 8. So Caden's yelling to me, y equals x squared plus 6x plus 8. And I'm like, let me think. X is negative 3. What does y equal? And Caden's going, y equals, right? So what do I do to figure out what y equals? Y equals negative 3 squared. Negative 3, because that's what x equals, right? That's what x equals. Negative 3 plus 6 times what? Negative 3 plus 8. Okay. So I have the equation to tell me what y equals, as long as I know x. So y equals negative 3 squared, which is positive 9. Negative 3 times negative 3 is positive 9. Plus 6 times negative 3, which is negative 18, plus 8. So y equals, let's see, 9 plus negative 18 gives me negative 9 plus 8. So y equals negative 1. The vertex needs an x and a y. So when x is negative 3, what does y equal? Negative 1. Now I know my vertex. Okay, here's my vertex. So we're going to go down over to our graph, and we're going to put that point on there, negative 3, negative 1. Okay. Now, up until now, once we got our vertex, we just did a rough sketch and we're like, we're good. Okay. But now we've got a little bit more information, right? This is the axis of symmetry. That means if I fold the paper on that line, both sides of the parabola will match up. Okay? So if I were to fold the paper, right? And then I wanted a matching point. That matching point would be on the other side of the axis of symmetry, right? How far away is this point from the axis? How many units? 1, 2, 3, right? This is -3, so it's 3 units away. That means that this point will be 1, 2, 3 units away. There's the matching point right there. If I were to fold the paper, that's my matching point. That gives me a better shape of my parabola. There you go. Yes. This point right here, this is my y-intercept. Remember we said the y-intercept is 8 because it's the c value? Okay. So this form of the equation gives me a little more information so I can get a better sketch of the graph. Okay. It's a little more work though. Okay, we're going to do another one. Okay. Let's do y equals, I'm trying to pick examples that don't have too many nasty fractions in it. Let's do x squared. Right, that one's going to give me a fraction. Let me see here. Can I have an example in the book here? Shoot. How about x squared plus we can do, wow, that's just not going to work. All right, we'll do 8x plus 16. It's going to be a big graph, but I'm just trying to find numbers that are not going to be fractions right now. Okay. Okay. So I've got to draw a big graph. Why do I know that that's going to be a big graph? It's a 16. Yeah. Okay. The y-intercept is 16. Okay. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Okay. So again, ax squared plus bx plus c, right? So my a, what's a equal? 1. Okay. B equals, and C equals 16. Okay. So my y-intercept, over there. My y-intercept is the C value, which is 16. So we plot that on the graph, 16. Okay. The next thing we have to find is the axis of symmetry. Okay, the axis of symmetry. We use the formula x equals negative b over 2a. So we use that formula to find the axis of symmetry. So x equals negative b, so that'll be negative 8 over 2 times 1, which is negative 4. So my axis of symmetry is -4. Okay. So I'm just going to sketch that in there. Oops. Okay. There's my axis of symmetry. And that's not really part of the graph. We just have it there so we can visualize it. Okay. All right. Now I need to find my vertex. Okay. Jonah, what do I do to find my vertex? All right. I already have the x. Brooke, what is the x of my vertex? -4. Okay. Jonah, how do I find the y of my vertex? Y equals, what does y equal? Okay. Are you taking notes? All right. So y equals x squared plus 8x plus 16. So what am I going to do with that x? We're going to, Anya, what are we going to do? We have x. If I have x and I want to find y, Caroline, what do I do? Yeah, plug it in, plug it in, plug it in, right? We've got our x, we want to find y. So it's -4 squared plus 8 times -4 plus 16. Once we get the axis of symmetry, that's the x value. To find the y value, I plug it in. So y equals +16 minus 32 plus 16, which equals 0. So the vertex is the point -4, 0. That's the vertex. Now on the graph, we put our point, -4, 0. Okay. So we're so close, right? We have part of the parabola. We have part of it. How do I find the other side? Yeah, it's symmetric, right? So this is 4 units away. I know that because I'm counting. So I'm going to go 4 units on the other side. And I put my point there. So there's the other side. Now I can draw the rest of my parabola. Okay. Make sure, because I will take points off for this, that this is curved. We don't want a V, because a V is an absolute value equation. It needs to have that curve. Yes, Yana, question.
So, you know how like we moved over 4 spaces?
Mm-hmm.
Did we get that from the x?
Yes, that's exactly right. Got from that. Okay. Okay. You have a worksheet in Google Classroom. There are 4 problems. Okay. You're going to graph it from the standard form, just like we just did. Okay. So that means you have to plot, you have to find the y-intercept. There's 3 parts to it. The y-intercept, the axis of symmetry, which is right here, and then the vertex. There's 3 parts to it. Okay. Later, we're going to figure out how to find the x-intercepts, where it's crossing the x-axis. Jonah, you with me?